And that way, if you missed anything, you can go back or you can study it and watch it again, or you can try the quiz again. It's on the Canvas. You can, print it off, go from scratch. And I mean, do it that way. There's all sorts of options for you. I know the weekend is probably not your favorite time to do schoolwork, but this is our last test or whatever for spring break. So then you get a whole week off and then, you can do what you gotta do. Okay. So number one basically just says, please create a 93% confidence interval for the average number of emojis sent by teens per day. So all your information is up there in the paragraph. Hopefully by doing these a couple of times, you guys are starting to get familiar with what to look for so that you can actually set these up correctly. So the numbers they gave me, 74 emojis per day and 28 as my standard deviation, both come from the 52 selected sample of teenagers. So before I even get started, I'm already aware of one of my assumptions. I'm going to have to use T. Nothing from my paragraph came from the population. And then when I'm trying to find T later, I made a little note up here that whenever you do inverse T, since there is no left, center, or right option on inverse T, so if you go in there, I think it's in, number 4, I think is the inverse T. It just asks you for the area and degrees of freedom. Well, what it does is it expects you to put in for your inverse T the area, including that left part of the area there. So I have to kind of do a little bit of math to go, all right, if I'm doing a 93% confidence interval, meaning my graph wants 93% of the data in the middle, how much is left over from 100? 7. And then the left part is going to be half of the 7, so that's 3.5% of the area. So I add that back into my 93. When I go to my calculator, I actually need to type in 0.965. Please don't forget on the T to add in the left half of the graph. Because if you don't, you're going to be off a little bit on your T-score, and then your answers are going to be rounded a little bit differently than they're supposed to be, and you're going to get questions wrong on your test. So that's the one thing I think is going to trip up people if they're just not careful and pay attention to the details. And then degrees of freedom, when you get to that part, are always just one less than the sample size. Anyway, there's my work. So I got my 3 assumptions. Overall, everybody's hypothesis test and confidence interval quiz, both of the works on all those look really good. There was very few people that had missed up the work, and I let them know through comments and stuff. So I'm pleased with the progress and how things are going in this class. So I don't think writing one of these from beginning to end is going to be difficult for a majority. All right, there's my calculations. Again, I write all my stuff over here just because I don't like to look it back up in here. Word prop, I hate reading over and over again. So once I find it, I write it. I can plug everything into this formula. Again, I'm using T because I don't know the population standard deviation. There's my 2 numbers. And then my sentence comes from the bottom of that little cheat sheet that you guys just picked up. It has it right there, word for word. So we were 93% confident the true population, blah, 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 is between 66.8 and 81.1 emojis. Do watch out. Probably in Canvas, you don't have to type in the labels, but on paper, if you got to do that, don't forget your labels, especially if you guys are going to do the AP exam later. For averages, labels are important. All right, any questions on part A? Easy peasy lemon squeezy. All right, are we awake yet? It's Friday. It's going to rain all weekend, so now if you had chores outdoors, you don't have to worry about it no more. That's what I like about rainy weekends. All right, part B. Interpret the confidence interval. So this is the other sentence, the middle one at the bottom there. If we repeatedly took samples of 52 teens and calculated 93% confidence intervals, approximately 93% of these intervals would include the true population mean of emojis sent by teens per day. So there's my interpretation of my previous interpretation, because why not? It's fun that way. All right, you good? Questions? All right, parts C and D. All right, for part C, this is where we start doing some hypothetical work based on what we know. So it says, if I want to know the mean number of emojis sent by teens was actually different than 70, what significance level, meaning what alpha, would I use to get corresponding results with a hypothesis test? So what this question is saying is, if I've done this confidence interval of 93%, how should I set up my hypothesis test so I get the same reject or fail to reject information? So you don't actually have to do the hypothesis test itself. You already know the answer. Because if we're doing a confidence interval of 93%, again, how much area is left over on each half of the graph here? 3.5%. Well, we have to decide, are we doing a one-tailed or two-tailed test if we want to know that things are different than 70. So we're doing a two-tailed test, which means that we're going to include both 3.5s, the left and the right. We don't care if it's greater than or if it's less than. We just want to know if it's different. So we're going to test both sides, meaning I got to add these together, or the entire 7% is what I'm going to use. So as far as justifying your work, a picture, a small little sentence like this, an equation, something is all you need. Don't just put alpha equals 0.7 and move on. Show some sort of like cognitive ability that you got from A to B. All right, so I wrote that this is what my alternative would look like, different than 70, which means two-tailed tests. Use both sides, equal 7%. So something like that will get you guys full credit. Does that make sense? We got questions there? All right, for part D, it's saying without actually doing the hypothesis test, with these two as your null and alternative, what would your hypothesis test conclusion be? Basically, are you going to reject or fail to reject the 70? Well, you already know that answer because the confidence interval is basically a hypothesis test in reverse. So look at this 70 right here, HO average equals 70. Go back up to the top where our interval was. Does 70 fit inside of this or not? The answer is yes. 70 fits right inside there. So if 70 fits between your upper and lower limit, then guess what? You're going to fail to reject it because it's a good number. That's all that means. You don't have to do the hypothesis test. You already know or expect your answers to be between 66 and 81, basically. And 70 fits right smack dab in the middle of that. So we would fail to reject the 70 is within my 93% confidence interval. Therefore, the p-value, if we actually did the test, would be greater than alpha, and there would be not sufficient evidence to reject it. So please don't feel like when you see this, like, oh, I got to kind of squish in this hypothesis test. Mr. D doesn't love me, doesn't give me any more space. No, I just want you to understand the difference between confidence intervals and hypothesis tests. They're basically the same thing. One gives you the interval, one tests your sample. That's it. All right. Again, any questions on these two? Because this is probably more like what your multiple choice questions will be on your exam. Like I might ask Michael, what would my alpha be if I'm using a 93% confidence interval and I'm doing less than? So Michael would have to know, oh, that's a one-tailed test with 3.5% of the area left over. Alpha would be 0.035. Or I might ask Cole, would my hypothesis at this be rejected or failed to be rejected based on a 93% confidence interval? He go back, oh yeah, my interval is this. It fits inside of it, I'd fail to reject. So these are probably going to be more in line of what your multiple choice questions are. If you're wondering, how's he going to multiple choice this stuff? I'm probably going to throw some one, like probably going to have two really dumb answers, and there's probably going to be two really like, either one of those would work. Just like it always is. All right, we're good? Making sense, Hope? I always feel like I stare at everybody else. I just don't turn front of it. You're good. The best seat right there, so you don't. So I don't have to look at it. All right, number two, there's a whole bunch of, hey, did you remember the ad from like the 1940s where the turtle and the owl discuss the whatever? Basically, the most important part at the beginning of number two is that all of our data is normally distributed. We're going to try to calculate basically what the original average was from his sample that got him the 289 and the 332 for his confidence interval here. So number one is basically that. What is the point estimate he used to create the confidence interval? Well, remember this word here, point estimate. I didn't underline it earlier, I should have. Point estimate just means the middle number. Okay, so whenever you see this, basically what's the average between your upper and lower extremes here? So I add them together, divide by 2, boom, 310.6. All right, it's just a fancy term for what was the original number that we used to get the left and the right limit, or the upper and lower limit, or whatever you want to call it. Again, this is an average now, not a percentage, so it doesn't have to be a decimal, and it should have a label. Number two then says, all right, with this information, the original point estimate and the confidence interval and a standard deviation and all that good jazz, what would the confidence interval be that he needed in order to get these numbers? So we're reverse engineering this formula right here. It's on your little cheat sheet. It's in your notes. The margin of error is equal to, in this case, the t-score. We can do this with z as well, but in this case, the t-score times the standard deviation over the square root of n. So why am I using t this time? Well, my standard deviation comes from what? The sample. So again, that tells me I can't use z. I don't know the population standard deviation. So I have to use t on this All right, so we can plug in things. So we know what the standard deviation is for the sample. That's 46.1. That comes from here. We know what the sample size is of this. He sampled 20 Tootsie Roll Pops, so the 20 goes there. But where did my 2158 come from? Well, that's my margin of error. How far the middle number is, right? The average X bar from one of these two extremes. It doesn't matter which one you subtract it from. You just need to pick a direction and go with it. Mr. G likes positive numbers and Mr. G is lazy. So I go 332.18 because it's a bigger number minus my point estimate, and I always get the distance positive. I don't have to convert nothing. That's just the way I do it. So pick a direction, practice it, do it the same way every time, and you won't have a problem. So I get 21.58, the distance between this number and my upper limit. That's my margin of error. It does not have to be completely in a decimal form this time because, again, it is not a percentage. So Elizabeth doesn't have to go back in there and convert it to like 0.215. Like, don't do that. It's an actual value. It's 21 licks off of what you expected it to be. So once you plug everything in, the easiest way to do this is to just figure out this number over here and then do 21.58 divided by this answer. That gives you plus or minus 2.0935. So that's your T value, your T score. So if you go into TCDF, these are going to be the two numbers you use over and over again. So TCDF, I believe, is number 6. So second vars, we go down to number 6. There it is. So don't use TPDF. We never use that one. Go down to number 6. And then it's going to ask you for an upper and lower limit. So what do you put in there? This number, twice. The -1 goes in the lower, so 2.0935. And the positive one goes here, 2.0935. So again, on the back of that little cheat sheet, if you don't know all these calculator steps or what to do, this is what I would write down later when you're watching the video. All right, what are my degrees of freedom going to be? Well, since I have 20 as my sample, I'm going to do 19, one less. And this is where you see my percentage come from. So that's where I got 0.950047. I was measuring the space in between the lower T-score and the upper T-score. So I wanted the stuff in the middle. So there's no infinity on this one because I'm not going outward, I'm going inward. Because the confidence interval is where? In the middle of that normal graph. So we want that space in between. Now, if you want to be fancy schmancy and you did a two-tailed test on this, guess what it would be? Well, there's 5% left over, so alpha would be 0.05. All right, so keep making those connections and see how things are going for you. Any questions on that? We okay with this, guys? Things I can help with? Lost, confused, hopeless? No.
And same reason I asked the same question.
Sure.
Just want to make sure using Z or T.
Yes, sir.
We didn't get the population standard deviation.
Correct. Yeah, so right up here, you can see it says sample standard deviation. So I automatically know just by reading that I have to use T. Yep, very good. And if you're worried that you're using T when you're supposed to use Z, you'll know because when you go into the calculator, what's the first thing you notice that you're missing whenever you do a T distribution when you should be doing the normal one? It says degrees of freedom. Well, if you don't have a sample to do degrees of freedom, and can you use the T-score? The answer would be no. So then you know, okay, well then I have to use the other one. So that should help a little bit, Cole, on which one that you need to work on. But yes, that is an excellent question. And anytime you're doing the samples, standard deviation, it's T. Anytime it says population, standard deviation, you use Z. Yes, excellent. Any other questions before we look at number 3? All right, number 3 says he claims that the mean number of licks is actually 339. So whenever somebody's claiming something, that's their null hypothesis. The average is equal to 339 licks. Got my label. So basically, does the evidence that we've gathered support or refute the claim? So I take 339 and I go back up here. Does 339 fit into this confidence interval? No. So we're going to say the evidence collected refutes the claim. Explain. 339 licks is outside / above the 95% confidence. What I just did there was a very raw, without all the steps, hypothesis test. I would reject the null because evidence supports that the alternative is true, that it's not that. So you don't have to write this part as your answer. I just wanted to remind you guys, anytime you're asking to refute or support somebody's claim, in order for it to be refuted, the entire confidence interval has to be above or below what you're trying to figure out. If it's inside at all, then it supports it. So it needs to be completely outside of it. We had this discussion. I put that on there just because we had this discussion yesterday in 5th period about, it was like a question about a politician is looking to run for office, and the confidence interval said he had between a 46% and a 52% chance of winning or something. And the student I was talking to was very confused that the newspaper couldn't make the claim that he was going to win. I was like, because the whole confidence interval is not above 50%. He technically could only get 47% of the vote, and then what happens? He loses. So therefore, the newspaper would look like an idiot, and some do in real life, if they made a claim that somebody was going to win when they're not supposed to. So just keep that in mind. The entire interval has to be above or below your thing in order for it to be true, false, whatever, support, refute, that kind of stuff. All right, last part on this one, part B. Richard's brother, David, decides to, David, I didn't know you had a brother named Richard. Decided to do a similar experiment, blah, blah, blah. Basically, he wants a margin of error to only be 15. So earlier we had 21, and he wants the confidence level to be 92. Earlier we had 95. So basically you're redoing his confidence interval, but this time to help with Cole's question earlier, see what it says there, population standard deviation, so it's a difference. So this one tells me now I have to use Z. This formula is in the slides. It's not on your worksheet I just gave you, that little cheat sheet. So you might want to write this one down when it comes to finding the sample size of one of these questions. This is for means. All right, this is not the same one for percentage. There was another one for percentage. The one for percentage was this one. All right, so this one's for percentage, this one's for means. They're different formulas. Don't try to use one with the other because, oops. So this one, the M has to be a decimal. This one, it does not. All right, so this one's for whatever we call it, proportions. Mean. So if you want to write those down, so you have the little cheat sheets for those. Otherwise, you got to do the algebra from the margin of error formulas, which you can do, but not everybody likes algebra. So I don't know what you might love algebra. Didn't do the algebra. I don't like algebra. These are for whenever you want the sample size needed. So typically they're for the confidence intervals. But whenever the question asks, basically how many something should be sampled, that's what these are for. So this would be, again, for proportions, right, where I'm looking for like a P or a P hat type question. And then this one would be for means, where I'm looking for like an X or X bar type question. So I just thought I might throw that out there. We've already done the algebra in class. You may have written it down. You may have been sleeping that day. You may have been texting. I don't know. So I'm just putting it in. Emily's always sleeping, so I just put it in. All right, everybody got them? They're on the video too if you want to go back and look at them. Okay, so anyways, let's go back to this problem. What are we trying to do? We're going to use this one. We know what our margin of error needs to be. We know the population standard deviation is 42 licks, so we just plug everything in. We get 24.0292. Always, always, always round up. All right, give yourself that extra person or extra item to make sure that you're not giving too small of a sample. So we'd go to 25. The other thing I noticed, and I don't know if this is true all the time, but this is something that maybe for those of you guys who are really into this and paying attention, for whatever reason, it seems whenever you're finding the sample size with averages or means, the numbers seem to be a little bit smaller than when you do it with proportions. So like for proportions, it's always like 800 people, 1,000 people, whatever. And for these, it always seems to be like 25, 46. So I don't know if that's for a reason. It's just something I see patterns all the time. So I just for some weird reason. You guys may like, shut up, Mr. G. Oh, sorry, just what I said. I just put myself in your guys' shoes. If I'm in class, I'm looking for every hint I can get, so I don't have to think about this thing. Okay, last page, number 3. So now you do a full-on hypothesis test, beginning to end. Again, the quizzes I looked at, you guys are doing very good with this. I put some comments in the quizzes. I will open those up later for you guys to look at to study. We've got a few other classes that haven't taken it yet, but then we'll do some. Basically, these builders of condominiums claim their total square footage is 1,500, but a random sample of 35 shows that of that sample, it's only 1,488 and a standard deviation for that sample of 24.25 feet squared. So we got an issue. The builder claims 1,500. We're seeing a lot less. Doesn't seem like 12 square feet's difference, but it is. So you got to write out your hypothesis. We have our original, that it's 1,500, or our alternative. In this case, we're looking for, is there proof at 1% alpha that we have less than the advertised number? So alternatively, it should be averages less than 1,500 feet squared. Define your average. U is the true population mean square footage of condos. And then I write up here in my little corner, alpha equals 0.01. So I don't forget later, because I'll get busy doing my steps and then think it's 0.05. All right, write your assumptions. It's random. It said so. We're using T again. Why? Because this is the sample standard deviation. So check. And normal, how do I know? N is sufficiently, in this case, large, 30 or bigger. So again, all of your assumptions are on that little page right here. So just go through them step by step. All right, calculations. Here's the formula you need. It has to be T because we don't know the population standard deviation. So here's X bar from the problem. Here's the standard deviation for the sample. Degrees of freedom is 34 because my N is 35. Alpha is 0.1. Plug everything in. Boom, 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 boom. Type it into the calculator, press enter, and I get this for my t-square, or my test statistic if you want to be official. Negative 2.9275. Now, how do we convert this to p-value? Do you guys remember? Yes, exactly right. Put into the calculator for your CDF and then do this one as the upper limit because you're going to the left on this one. Very good. Excellent call. And then after you type it in and you get your answer of 0.0030, I see that that is less than alpha, which means I reject the original hypothesis. Boom, it's fine. So then you can write your conclusion. I'll move it up so you can see it here at the bottom. Since the p-value is less than alpha, I reject the original claim or the null hypothesis that the average is equal to 1,500 square feet. There is sufficient evidence, according to my test, to suggest that the alternative is true, that the average is less than 1,500 feet squared. Which is going to lead us to, again, what your multiple choice portions of the test might be, parts B and C. Look at this from the other side. All right, so for part B, I see people still writing, so I'm not going to move it yet. What confidence level should we use if we wanted to make a confidence interval? Basically, what percentage should be in the middle to give me my upper and lower limits in order to have an expectation of what my answers should be? All right, so go back and look, what was my original alpha? And what kind of test did I do with my original alpha? A 1 or a 2-tailed test? So if I do less than, what does that tell me? 1 or 2-tailed? 1, very good. All right, is anybody still writing the calculations part? Oh, yeah, no problem, no problem. So if it's a 1-tailed test, you can kind of draw the normal curve, you'll see it here in a second, on B, and put the 1% on the left side of the graph. And then remember that your graph is always symmetrical. So how much percentage is on the right side of the graph that you didn't use? 1%. So in total, you've used up 2% of your graph for your alpha, even though you only used one of them. So how much area has to be left over in the middle if each end only has 1% on it? 98%, very good. So that's going to be their answer for part B. You're going to use a 98% confidence interval. There's my picture, my graph to prove what I'm saying is not total BS. So if alpha is equal to 0.01 and we have that our alternative is less than something, that means we did a 1-tailed test. Cole said this exactly right. So that means 1% of our area that we were testing at was right here. But the graph is symmetrical. Even though we didn't use it, there was 1% over here. Therefore, what's left over in the middle is 98%. Which leads us to part C. Move it up just a smidgen. There we go. Without doing the confidence interval, which I actually did, so you guys can see the interval here in just a second. Without actually doing the confidence interval, would you expect to get 1,500 in the interval, and explain why? So what did we just do with our 1,500? Did we reject it or fail to reject it? We rejected it, meaning it was bad. So therefore, no, we would not expect to find it in the confidence interval because we threw it out. We already verified that it does not fit into the expected range of data for the average condo square footage. That's what your hypothesis test just did. Without actually looking at the interval, we just proved that 1,500 would not be a reasonable claim. If you're curious of what the actual confidence interval is, you can write it down. There it is right there. So based on our sample of, what do we get, 1488 feet squared, we would expect all of the condos 98% of the time to be between here and here. And 1500 is where? Just outside of this. So adios, amigo. Yeah. And we throw it out and we accept that the alternative is true. What is the alternative? That the square footage is actually less than 1500. So if you're really getting into this, again, the cool thing is you didn't prove what the square footage is. You just proved what it isn't. We proved that it is not 1500. So at the very least now, if you're into the business of advocating for people who need help, or you're defending a client who's feeling like they were getting ripped off from the builder, you now have evidence you take to the court and say, I don't know what the square footage is exactly, but it ain't the 1500 we've been paying for. We want our money back. And you probably win because everybody's sitting in the thing goes, oh man, Elizabeth wrote up a nice report. That looks really good. What's that? Yeah, they'll be like, I don't know what the heck they're talking about, but it sounds smart. So yeah, we'll agree with them. If that's something you're interested in. If you're not, then you just do this for your test, you get your grade, move on. I don't know what you guys' career choice is going to be. You probably don't know what they're going to be yet, but you can use this kind of stuff anyway for all sorts of things. Replace it with a sports thing if you're into sports. And I can go, no, the average 40 time on a football team is whatever. And you're telling me the kid's running what's a really low 40 number, like a 3 something? Like it ain't happening, Chief. Everybody's at least a 4 to 4.6, 40. Like, I don't know what kind of BS you're spewing to me, but I ain't drafting him. He's probably lying or he's on steroids or whatever. Or you take the chance on him because you're like, this guy's outside the range. This guy's really rare. I don't know. Like you're the one in charge. You have the statistics. You make the decision and then live with the decision later. All right. Any questions on this, guys? What you got, David? You don't have to calculate it while fifth and sixth period yesterday was doing their thing. I got a little bored after I graded and I was like, I'll just do it real quick. So I popped in the calculator and did their thing. You don't have to do this though to prove it. I just wanted you guys to see, because some people like myself are very visual. So I just wanted you to be able to see, really, we did prove this already, that 1500 would be rejected, and here's why. Sometimes it helps make that connection. You're talking about confidence interval or up here for this, or which one you're talking about? This one here? I just did one of these on a piece of paper. So I plugged in the X bar, which was 1488, and then the standard deviation was 24.25, and the sample size was how many condos? They look at 35. And so I just plugged all that in. I figured out T needed to be, I didn't write it down on this paper, but we had we were going to use a confidence interval of 98%, right? Because we had 1% there. So I just used whatever inverse T at 99% is so I can include that left tail. And then they gave me my 2 numbers. So you don't have to do that. Please don't feel like on a test, unless it specifically says you have to do that to verify it. But they were busy working on whatever, because we had some, fifth period always has the most time out of all my classes because 6 periods lunch and this is always 0. So I just did it. Just again, so you can see it visually that we actually already proved that, because it just kind of helps sometimes to say, oh, that's what Mr. G means by we reject the HO. It just doesn't fit inside the little. Very good, sir. Any other questions? Let me see what chat's saying, because I don't have nobody's saying nothing in chat. Everybody's sleeping at home. You guys aren't logged in at home. Bunch of liars. You guys are sitting there in your PJs, with your screens off, sleeping. This is my voice putting you back to bed. All right, we're good? All right, so test is Monday, Tuesday. Please don't be surprised when you come in and I'm like, go ahead and get started on your test. It's Monday and Tuesday. There's 2 parts, multiple choice, free response. Feel free to pick whatever one you want to do. I've learned it's probably just best let you guys go with whatever you feel comfortable with. They will both be open on Monday, but you will only have time to do one of them. And then on Tuesday, you guys come in, you do the other one. And then they're going to give me an assignment that will supposed to count for attendance on Wednesday. Do not log in on Wednesday morning early. I won't be here. Don't walk to the STEAM Center at 7:30 on Wednesday. I won't be here. You're going to get all the way up here and be mad that the building's closed. It is a SAT testing day for juniors at the high school. If you're a sophomore and a senior, you will go to no classes physically on Wednesday. You will stay at home. No matter what learning style you have, Wednesday, sophomores and seniors will stay home. All of your teachers that you have on Wednesday should be putting stuff into Canvas, in theory, that you're supposed to do to get a credit for attendance. So I don't know exactly what ours is yet. I will tell you next week when I have it officially logged in and loaded up. The nice thing about being in zero period is if it's required for a grade for the fourth 9 weeks and you don't get it finished Wednesday, as long as you're in there showing me that you exist, you'll get attendance, and you'll probably have Thursday and Friday to finish working on it, because we have 2 full hours after Wednesday where we have nothing to do. I'm not teaching anything the rest of spring break. I can't do grades for late people after Monday because they got to be in. So it's really just like, hi, how you doing? We're all just sitting here pretending like we're doing something important, because they pretty much locked off all of our ability to do anything other than busy work. So there you go. Just being honest with you. And then spring break, it's early release on Friday next week, but it doesn't affect this class because they don't love zero period. So sorry, it's still full hour. I know everything. If you want to just be absent one time, then just don't show up. Like, not gonna hurt my feelings. I didn't say that out loud. All right. Adios, guys. Have a good day. Go for it.